Okay, this video is an instructional video on how to solve two-step equations, specifically basic two-step equations. We're going to get a little bit more complicated by adding in some parentheses and some binomials divided by monomials, but for now we're just going to do some basic questions. So let's start with this example. 8n plus 7 equals 31. So I need to try to isolate my variable n. So I need to look at what are all the things that are being done to my variable. Well, my variable is there's a 7 being added to it, and it's being multiplied by 8. Now the order that you want to do this in, you want to kind of start with anything that's like not directly attached to the variable. So this 8n is directly attached to the variable, so we want to try to get rid of this plus 7 first. We'll deal with that first. So if we want to get rid of a plus 7, we need to do the inverse operation. So we need to subtract 7. And if we subtract 7 from one side, we need to subtract 7 from the other side as well. This will cancel out, giving me 0. So I just end up with 8n plus 0, which we just leave as 8n, equals 31 minus 7 is 24. Okay, so that's my first step, but I still have a number attached to my variable, and I want to have it by itself. So I need to find a way to get rid of that 8. So that 8 currently is being multiplied by the n. So I need to get rid of a multiplied by 8, so I will do the inverse and I will divide by 8. So 8 over 8 just means 1, so 1n or n. And if we divide by 8 on one side, we have to divide by 8 on the other. So 24 divided by 8 is 3. Okay, and that is my answer, n equals 3. And of course we could verify by substituting our 3 into our original equation, and we would end up with 24 plus 7. Does 24 plus 7 equal 31? Yes, it does. So I know that my answer is correct. Okay, let's try another example. This one involves some division at the start. Equals 6. So 3 plus x over 4 equals 6. So again, I've got two things going on with my variable here. The variable is being divided by 4, but there's also 3 being added to it. So the first thing I want to do is get rid of this plus 3, or this positive 3, because that's not directly attached to the variable like this 4 is. So I'm going to get rid of it first. So if I have a positive 3, I'm going to get rid of that by subtracting 3, because subtraction is the inverse of addition. So that cancels out. But I must also subtract 3 from the other side to keep these equal. So I end up with x over 4 equals 6 minus 3, which is 3. So now I still have this divide by 4 attached to my variable. So if I want to get the variable by itself, I need to do the inverse of dividing by 4. The inverse of dividing by 4 is multiplying by 4. So whatever I do to one side, I have to do to the other. These cancel out, because that's why we use inverse operations. They undo one another. And I'm left with just an x. 3 times 4 is 12 for my answer. So x equals 12. And if I want to verify, I write my original equation down, and I substitute in 12 for my variable x and see if it in fact does make sense. 3 plus 12 divided by 4. Well, we know 12 divided by 4 is 3. And then we can add 3 plus 3 is 6. So that works. Okay, one more example. This one might look like it's a one-step equation, but it's actually a two-step equation. Negative x plus 5 equals 10. Okay, so it looks like, oh, maybe I'm only doing one thing to my variable x. I'm adding 5. But we have to remember that this is actually a coefficient of -1x. So not only are we adding 5 to our x, but we're also timesing it by -1. So we are doing two different things to it. So we'll deal with the plus 5 first. We'll do the inverse operation by subtracting 5. And that cancels those out. I must also subtract 5 from the other side of my equation. So then I'm left with a -1x, or just a -x, we would say, equals 10 minus 5 is 5. Now it might look like you're kind of done. You've got x by itself, but it's not really by itself because it's got a -1 attached to it. And we always want to know what the positive value of x is, not the negative value. So what we would do here is, if we have a -1 multiplied by x, we have to do the inverse operation and we have to divide by -1. So that would get rid of those. If I'm dividing by -1, I end up with x equals positive divided by negative is a negative answer of 5. So the number doesn't change, but the sign changes in front of it. So whenever you end up with an answer like a -x equals 5, all you need to do is move that negative to the other side. But the way that we do that, I just wanted to show you, is you're actually dividing by a -1 on both sides. So we should verify our answer. We have a -x plus 5 equals 10. And if we substitute in, for the value of x, a -5, and remember, we have to keep this negative and only change the x becomes a -5. So this negative still stays, and then the -5 is what's in the brackets. Plus 5 equals 10. So we know a negative of a -5 is a positive 5. Plus 5 equals 10, and 5 plus 5 does indeed equal 10. So we know our answer is correct there. So you have to be really careful when you're substituting in here that the negative is not part of the x. You're just substituting that -5 in for the x, but this negative on the outside has to remain. Okay, so that's how to solve some basic two-step equations.